In this example, I'm going to solve this equation by factoring. So the first thing I need to do is to take this negative 135x from the right side and move him over to the left side. So 3x cubed plus 135x equals 0. And since I'm solving this by factoring, I need to fully factor this left side expression. Well, the first thing I notice is that I have a greatest common factor between these two terms of 3x. So when I pull that out, what's left over is x squared plus 45, and that equals 0. Well, the x squared plus 45 I could factor using the sum of squares factorization. So the square root of x squared will be x. Since it's the sum of squares, one will be negative, one will be positive. And then the square root of 45, well, 45 is not a perfect square, so I'll put square root of 45 with my I, square root of 45 with my I. Well, what I can do next is go ahead and simplify the square root of 45. And 45 comes out to be 5, gives me a 9, 3, and another 3. So it looks like I have a pair of 3's. So this will simplify as x minus 3 radical 5i and x plus 3 radical 5i, and that equals 0. So since my left side is all multiplication and it equals 0, I know that either this is 0, or this is 0, or this is 0. So I'm going to go ahead and take into consideration all three. So 3x equals 0, x minus 3 radical 5i equals 0, and x plus 3 radical 5i equals 0. And go ahead and solve for x in all three cases. So here x is 0. When I add 3 radical 5i, I get x equals positive 3 radical 5i. And when I subtract it, I get x equals negative 3 radical 5i. So the last step then is to go ahead and write our solution with one single line here. So x equals 0 comma plus or minus 3 radical 5i. And that's the solution to this original equation.